Have you ever wondered if we're alone in the universe? Well, get ready to embark on a journey through space as we explore the thrilling search for life on other planets. From alien oceans to distant galaxies, this video will leave you in awe and inspire you to join the quest for extraterrestrial existence. Don't miss out on this incredible adventure. Watch now and join the search for life beyond Earth. The big question is there life beyond Earth? Comes with an ironic asterisk. We don't have a universally accepted definition of life itself. That said, we might not need one. We need only detect the telltale signs of life in an exoplanet atmosphere, and we have a better understanding of what those look like here on Earth. Will we know life when we see it? The James Webb Space Telescope, launched in 2021, could get the first glimpses of the mix of gases in the atmospheres of Earth-sized exoplanets. Webb, or a similar spacecraft in the future, could pick up signs of an atmosphere like our own: oxygen, carbon dioxide, methane, a strong indication of possible life. Future telescopes might even pick up signs of photosynthesis, the transformation of light into chemical energy by plants, or even gases or molecules, suggesting the presence of animal life. How will we find life? Life might turn up in our neighborhood, beneath the Martian surface, perhaps, or in the dark, subsurface oceans of Jupiter's moon, Europa. Or maybe the dream of the ages will come true, and we'll eavesdrop on the communications of extraterrestrial civilizations. We might even capture evidence of technosignatures or traces of technology, think smog. Barring these strokes of luck, however, the job will be much harder. Light will be the key light from the atmospheres of exoplanets, split up into a rainbow spectrum that we can read like a barcode. Where should we look? More than 4,900 exoplanets, planets around other stars, have been confirmed to exist in our galaxy, but they likely number in the trillions. One of the best tools scientists have to begin narrowing the search for habitable worlds is a concept known as the habitable zone. It's the orbital distance from a star where temperatures would potentially allow liquid water to form on a planet's surface. Many other conditions also would be required: a planet of suitable size with a suitable atmosphere, and a stable star not prone to erupting and sterilizing flares. The habitable zone is just a way to make the first cut and zero in on the planets with the best chance of possessing habitable conditions. Searching for ETs. Much of astrobiology research involves searching for chemical biosignatures, molecules or combinations of molecules that could indicate the presence of life. But because scientists can't reliably say that ET life should look chemically like Earth life, seeking those signatures could mean we miss beings that might be staring us in the face. How do we move beyond that? Johnson asks. How do we contend with the truly alien? Scientific methods, she thought, should be more open to varieties of life based on varied biochemistry. Life as we don't know it. Part of the difficulty in searching for a life of any sort is that scientists don't agree on how life started in the first place, or what life even is. One good attempt at a definition came in 2011 from geneticist Edward Trefanov, who collated more than 100 interpretations of the word life and distilled them into one overarching idea: it's self-reproduction with variations. NASA formulated a similar working definition years earlier, in the mid-1990s, and still uses it to design astrobiology studies. Life, according to this formulation, is a self-sustaining chemical system capable of Darwinian evolution. Alien life could have genetic codes with, say, different bases. NASA supported 2019 research from the Foundation for Applied Molecular Evolution, successfully created synthetic DNA that used the 4 old-school bases and 4 new ones: P, Z, B, and S scientists have also altered the strand part of genetic code, creating XNA, where X means anything goes, that uses a molecule such as cyclohexene, CNA, or glycol, GNA, rather than deoxyribose. Big thinkers have long suggested that rather than using carbon as a base, as all these molecules do, perhaps alien life might use the functionally similar element silicon, meaning it wouldn't have nucleic acids at all but other molecules that perhaps play the same role. If we can whip up such diversity in our minds and our labs, shouldn't the universe be even more creative and capable? The space agency would give them a chance to do so, soon putting out a call for interdisciplinary consortia for astrobiology research. It promised multiple years of funding to dig deeper into Johnson and her associates. Lunch table ideas. They needed a larger team, though, so they pinged planetary scientists, biologists, chemists, computer scientists, mathematicians, and engineers, some space-centric to the core and others. Johnson says, just beginning to consider the astrobiology implications of their work. It was particularly important to do this now because researchers are planning to send life detection instruments to destinations, such as the solar system moons Europa, Enceladus, and Titan, more exotic than most of the worlds visited so far. Most of these other places we're beginning to think about as targets for astrobiology are weird and different. Johnson says, if you're going to a weird and different place, you might expect weird and different life, squirming invisibly beyond the reach of a lamppost light. The pitch worked. Their pitch worked. The expanded lunch table became LAB. Now the project, a spread-out coalition of scientists from more than a single physical laboratory, is a few years deep into its work. The researchers aim to learn how things like the complexity of a surface, anomalous concentrations of elements and energy transfer, such as the movement of electrons between atoms, might reveal life as no one knows it. NASA works. Our early planet-finding missions, such as NASA's Kepler and its extended incarnation, K2, or the coming James Webb Space Telescope, could yield bare-bones evidence of the potentially habitable worlds. James Webb, designed in part to investigate gas giants and super-Earths, might find an outsized version of our planet. NASA's Nancy Grace Roman Space Telescope, or the Wide Field Infrared Survey Telescope, could zero in on a distant planet's reflected light to detect the signatures of oxygen, water vapor, or some other powerful indication of possible life. But unless we get lucky, the search for signs of life could take decades. Discovering another blue-white marble hidden in the star field, like a sand grain on the beach, will probably require an even larger imaging telescope. Designs are already underway for that next-generation planet finder, to be sent aloft in the 2030s or 2040s. In conclusion, the search for life on other planets is an exciting and ever-evolving field of study, and the cutting-edge technology of the Cherenkov Telescope Array is poised to revolutionize our understanding of the universe. Whether we find microbial life on Mars or detect signs of intelligent civilizations beyond our own galaxy, the discoveries made with the potential to reshape our perspective on our place in the cosmos. The quest for extraterrestrial life may seem like a lofty goal, but with the dedication of scientists and the power of advanced technology, the possibilities are truly endless. So let us continue to gaze up at the stars with wonder and curiosity, for who knows what secrets and surprises they may hold. Don't forget to subscribe to our channel so you won't miss on our videos.